Hey, juniors, going to come in here and especially you Wednesday juniors anyway, kind of go over what you need to do in class. Monday we divided people up into pairs, and so if you look at your materials in here as well, particularly, there's three things actually. So there's the basic stuff which hopefully you've read already. There's an online spreadsheet to work on for the Vostok Ice Core. It's just cookbooky. You should be able to figure that out pretty easily. And then there's this one. Now, with this one, I want students to look at individual climate events during the Cenozoic era. And that's the whole goal of this. Now, you'll see there's a list of climate events. Now, nobody in the junior class is doing the same. You're all paired up, but nobody's doing the same two events. And so you're going to be creating a 5 minute or less video that you can upload to Flipgrid, and then from which next week your fellow classmates can learn from. So we might group them together. We might make sure that the name of the video is in the title, or the name of the event is in the title of the video. You'll see the ones that the folks in red are the Wednesday juniors who have been assigned to work together in one of these. Since I'm not going to see you guys, you're not going to be in class, I have the chance to do this. I've already assigned you. I just went down the list, so no special. I didn't assign anybody especially on purpose. So anyway, some of these are harder to find things than others. You may have to go and dig into databases in Lord Fairfax's website, library, and that's perfectly fine. That's actually really good. I prefer you to do that. But you're really just trying to address these questions in your video. What are these different things? And give us a sense of what that time period was like versus today, right? And so that's one of the things that we're looking at. Now, I did go over with the other group just some basics. This slide, the other two groups, this is looking at temperature change over the course of the Phanerozoic eon. So from the beginning of the Cambrian period, a little over almost 600 million years ago to today. And of course, as you go back in time, the resolution becomes more coarse. But you can see what climate was doing. This is the Carboniferous, when the coal swamps that eventually became our coal deposits were being created. All that carbon was being sequestered into what would eventually become the Mississippian and Pennsylvanian coal deposits that we use now for electricity, which ironically are warming our planet now because we're taking all that carbon and putting it back in the atmosphere. Coal, petroleum, and so forth. You do that, of course, see some other big excursions. This zero is the datum here is based on the temperature, the average global temperature for the decades between 1960 and 1990. So for a 30-year period in the 20th century. So you can get an idea just, if this is where things were between 1960 and 1990, and you can see how that plays out over here on this end of the graph. You can see how drastic things were back in the Paleozoic, and then even in the Mesozoic, and even into the early Cenozoic. And it's only really been, note that the scale on the x-axis changes significantly. I mean, these cool periods we've been through are really kind of an aberration. If this was all the same scale, this would look a lot like this brief cooling period here. And so, that's something to keep in mind. Things being warmer than they should be to some extent would be not unexpected, but you wouldn't expect it to rise quite this fast. And so this is the projected warming at 2100. The thing that I want to point out here, if we look at the Cenozoic era, just the Cenozoic era from the beginning of the Paleogene, all right, the end of the Cretaceous, this is where the asteroid hits, the Paleocene, Eocene thermal maximum, and then the Eocene climate optimum through here and so forth. You can see what the temperature's been doing. And then, of course, at this point, we start having ice caps beginning to form, Antarctica and so forth. And then we into the Pleistocene, where things are just really, really bone-chilling cold, right? Into today. Now you'll note these are projections over here. These are the IPCC projections. So if we had the worst case scenario, we'd be approaching an Earth that was similar to, if we follow this line back, the Eocene. That's really hot, folks. There's no polar ice caps in that situation. And so when we think about climate change, we need to think about it from that point of view. It wouldn't happen automatically because there's always a lag in this stuff, right? The ice doesn't melt overnight, for instance, and then the ocean currents don't shift overnight. It takes some time. Likewise, it takes time for the CO2 to get in the atmosphere and the shortwave radiation to be trapped and all of that. So there's a lag. the CO2 that's up there right now, not all of it, as not all the warming that's going to come from the carbon dioxide, methane, and so forth that's up there has occurred yet. And what has occurred is going to be there for anywhere between 700 to 10,000 years. So we've got a long way to go with this global warming stuff. The bottom scenario here is a scenario where we not only stop emitting, but we also pull CO2 out of the atmosphere. Okay. So you can kind of see where the range of things are. We're going to get into the next week or two talking about the climate change today and what the future looks like a little bit before we change gears and start thinking about solutions to all these problems, right? And so this is something that's important to keep in mind. So when you're looking at your different periods within the Cenozoic era, and by the way, this is how seasonal temperature averages have changed globally from 1880, which is the blue line, to 2020, which is just recorded as the second hottest year on record. By the way, 2020. Another thing that 2020 can put in the record books. These are a few of the items here, right? Now we've reversed the time scale here. So this is now the present, and then this is the beginning of the Cenozoic era. But as you go through these areas and you think about what today's warming and the future projections look like, I want you to think about and compare where were we at the time when CO2 was 414 ppm and so forth, right? Anyway, so what you need to do is get together with your partner that's assigned here, and do that via Zoom or Google, whatever, and begin to work on it. So you guys need to take the initiative and meet. Okay, so do that, and then put together your video. You can record it however you want. You can upload it to Flipgrid, or you can record it in Flipgrid. It's up to you. But if you have questions, let me know. That's what you're doing this week.